listen up because today's warm-up question is going to be something you're going to see again in your assignment today. Today you're going to be taking a CFU, a quiz basically, but you're going to be taking it on your computers in My Open Math, and you will be able to use notes and discuss with neighbors. So it's a little different than our normal paper quizzes, and again, we're doing this because we don't have the extra day to be able to go over it. So I want you to be able to discuss it as you are doing it because you have a test tomorrow.
Is it due during class?
It's due by 11:59 p.m. tonight. Okay, but you have a test tomorrow, so it is obviously very important that you make sure that you feel comfortable answering all those questions, that you don't leave the room still not sure how to do things, because again, you're about to be assessed over it on your test tomorrow. All right, let's go ahead and take a look at the warm-up question, which says Mars, which has a mass of 6.39 times 10 to the 23rd kilograms, has two moons. One of those moons is named Phobos, and it has a mass of 1.06 times 10 to the 16th kilograms, and it orbits at a distance of 9,376 kilometers. Find the acceleration of Phobos as it orbits Mars. And we did a question like this yesterday as well. It helps to draw a picture of that orbital motion of Phobos around Mars, because then when you draw it, you can see, oh look, I have an object in uniform circular motion, which means obviously I would be able to find that centripetal acceleration. It is accelerating because it's constantly turning. Okay, we have a change in direction. And so I know that when I draw this, I can see that distance of separation is the radius of that circular path. And I can also see that my force that is attracting the two to each other, that force of gravity, is a centripetal force. And so I'm able to look at the information I have, because I don't have information to solve my problem using my circular motion calculations. I don't have the tangential velocity, okay, for example. I don't have the centripetal force. I can't just solve for the acceleration with those equations on my board. Instead, okay, I'm going to have to use the universal law of gravitation to solve for FG, because they gave me both masses and they gave me the distance between them. That's all I need. I can use that information to solve for the force of gravity, and then I can recognize, hey, that force of gravity is my centripetal force because it's what keeps Phobos in orbit. Okay, it's the inward force that keeps it in a circle. So we're going to, again, use the two different equations in the same problem. So looking at this, I'm going to label the information I have. I have a radius of 9,376 kilometers. That's the distance of separation between these two planetary bodies. I have the mass of Mars. I have the mass of Phobos. And I know my constant. Okay, I know my constant is 6.67 times 10 to the negative 11th. Those are its units, Newton meter squared per kilogram squared. And those units, again, give me a clue about the units that I should be using. And right off the bat, I see a problem. What is the problem that I need to fix before I plug numbers in? Yes, Nate?
Kilometers into it.
I need to convert kilometers into meters. Okay, so my first step is to get my radius in meters before I start plugging in any numbers. There are 1,000 meters in a kilometer, so I just need to multiply this number by 1,000, and that gives me, and I'm going to go ahead and put it in scientific notation instead of adding all those zeros, but it gives me 9.376 times 10 to the 6th power, okay, in meters. So with that, I can now plug into my equation, and when I substitute in, it looks like this. So I have my force of gravity is equal to my gravitational constant, 6.67 times 10 to the negative 11th, multiplied by my masses, and then divided by the distance of separation squared. Again, this distance is in meters. Hopefully you're typing this in, or hopefully you already did, because again, we do want to make sure we're not running into issues with using the calculator. And guys, I'm going to strongly encourage you not to use the calculator on your phone, because you can't use that tomorrow. Please use the calculator you plan to use on your test, okay, because that's the one you need to make sure that you're not having issues with. So whatever calculator that is, if it's your own, use it. If it's one of the Inspires that's in the room, grab one. Make sure that you're not having issues typing your answers in. Okay, so whenever you solve this, you should get 5.14 times 10 to the 15th newtons. And again, That is your force of gravity, and therefore it is also your centripetal force. It's the force that keeps pulling Phobos inward and keeping it in its circular path. That's not our answer, though, because we weren't asked to solve for centripetal force. We were asked to solve for centripetal acceleration, the acceleration of Phobos. And if I look at my circular motion problems, I can solve for acceleration if I know both tangential velocity and radius, which I don't. I don't know what the velocity is. Or I can use F equals ma and I solve for it that way if I know the force and the mass, and I do know those things. And so my next step is going to be using F equals ma, where my centripetal force equals my mass times my centripetal acceleration. The problem is I have two masses. Which mass do I need to use to solve this problem? Phobos' mass, because it says to find the acceleration of Phobos. So please don't use Mars's mass. That would give you Mars's acceleration. Okay, you want the acceleration of Phobos. So when you substitute in, this is my gravitational force, it is my centripetal force. It is equal to the mass of Phobos, which is 1.06 times 10 to the 16th. Times a, and again we're trying to isolate that variable to get a by itself, which means we need to divide both sides by 1.06 times 10 to the 16th, and that's what goes in my calculator. Okay, whenever you're dividing, some of you were still having issues with this yesterday. If you are dividing by something in scientific notation like this, you have to put it, well, either if you have it in like fraction format that the calculator does, as long as the whole thing is down there, you'll be good. Okay, or you can use the E button to kind of group the exponent with the number. However, if you're typing it out, okay, and you're dividing by 1.06 times 10 to the 16th, and you just have like a division sign, you have to put that whole thing in parentheses. That way, you're dividing by the whole thing. Otherwise, it's only going to divide by 1.06, and then it's going to multiply by 10 to the 16th, and it's going to give you some crazy large number. Your exponent's going to be really big. Okay, we don't want that. So please make sure that your exponent is correct. If it's not, that means that you're probably typing something in wrong. All right, so when you type this and divide, you should get 0.485 meters per second squared. If you did not get that number, please ask your neighbor to look at what you typed or raise your hand and ask me. But does anybody have a question about this warm-up?
You can have an acceleration that small?
Yes, it was that small with the calculation yesterday.
No, I got that number. I'm like, this is way too small for a planet.
Yeah, but if you look at the velocity of it, the velocity is actually pretty fast. Like yesterday, it was like 6,000 something, even with that acceleration. It has a really large orbit, so like the change in its direction, you know. All right, any other questions? Okay. All right, guys, then I'm going to let you guys get to it. For the rest of the class period today, you're working on that CFU, 802 Gravitation and Circular CFU. It is due tonight by 11:59 p.m. And again, because we end up with numbers that are sometimes really big and sometimes really small, you may need to end up typing in answers in scientific notation like we have been doing. Please make sure if you're doing that, if you're rounding that number, that you round it correctly. It will count it wrong if you round it wrong. Okay, so again, go ahead and get to work. If you have questions, again, you're welcome to talk to each other. This one is not going to give you multiple attempts without a point penalty. This is the one that's set up like a quiz. If you miss it, you're going to lose the points. Okay, so make sure that you are careful about it. It's basically an open note quiz, open neighbor partner quiz, however you want to think about it, but it's scored like a quiz. Now, if you do miss it, do it again anyway. Make sure you figure out what's wrong and that you can do it right so that you know how to do it for the test. Okay, if you do happen to finish this in class and you're looking for additional practice, don't forget you also have a unit summary. And that unit summary could be a daily grade redo. Maybe your CFU doesn't go that well. Hopefully it does. But if it doesn't and you need a redo grade, do that unit summary. It has additional practice problems and it is a redo if you need it for your lowest failing daily grade. I'm going to stop talking. You guys get to work. If you have questions, please let me know.